Hiccups. You'd think something this common would have a simple explanation. It doesn't. A hiccup happens when your diaphragm, the muscle under your lungs, suddenly contracts on its own. That sudden contraction snaps your vocal cords shut, and you get that little hic sound. Here's the part that stumps doctors. Why does the body do this at all? It serves no known purpose in adult humans. Some researchers think it's a leftover reflex from when our ancient ancestors had gills, a kind of muscle memory from before lungs even existed. Other researchers think it's connected to how fetuses practice breathing in the womb, since unborn babies hiccup constantly. Nobody has proven either theory. There is no universally accepted reason your body still does this. Doctors are basically as confused as you are. Next, the pain that hits when you eat ice cream too fast. Brain freeze, officially called sphenopalatine ganglioneuralgia, happens when something cold touches the roof of your mouth. Blood vessels near your brain suddenly widen to bring warm blood to the area, and that rapid change triggers pain. But here's where it gets strange. Your brain has no pain receptors. None. You could poke the actual brain tissue and feel nothing. So why does brain freeze hurt so much? The current theory is that your brain misreads the signal. It thinks the pain is coming from your face because the nerve involved, the trigeminal nerve, also handles sensation there. Your brain essentially panics, mislabels the source, and floods you with pain as a safety response. The problem is, that's still a theory. Nobody has fully mapped why this specific reaction is so intense, or why some people barely feel it while others end up on the floor. It's one of the most common pains on Earth, and we're still guessing at the mechanism. Third, that eerie feeling that you've lived this exact moment before. Déjà vu, French for already seen, happens to almost everyone at some point. You walk into a room and suddenly you're convinced you've stood in that exact spot, said those exact words at some point in the past. Except you haven't. Scientists have thrown a dozen theories at this. One says it's a memory glitch, where your brain briefly mislabels a new experience as an old one. Another says it's a timing error between the two hemispheres of your brain, where one side processes the moment a split second before the other, creating a false sense of repetition. A third theory involves the hippocampus, the brain's memory center, essentially misfiring and tagging a brand new moment as familiar. Here's the honest answer. Nobody knows which theory, if any, is correct. Déjà vu is nearly impossible to study in a lab because you can't predict when it will happen to trigger a scan. Some of the only real data comes from epilepsy patients, whose déjà vu is caused by seizure activity, but that doesn't explain why it happens in people with completely normal brains, too. Now for something that affects up to 10% of adults. Restless legs syndrome. If you've ever lain in bed with an overwhelming, almost impossible to ignore urge to move your legs, you know how disruptive this is. It's not anxiety, it's not a habit, it's a real neurological condition. And here's the uncomfortable truth. Doctors still don't know what causes it. The leading theory involves dopamine, a brain chemical tied to movement control, and low iron levels in a specific part of the brain. But this doesn't explain every case. Some people have perfectly normal iron and dopamine levels and still suffer from it every night. Genetics seem to play a role too, since it often runs in families, but no single gene has been confirmed as the cause. Millions of people are prescribed medication for a condition that medicine still can't fully define. That's not a failure of doctors. It's a reminder of how much of the nervous system remains a mystery. Fifth, the ringing in your ears that isn't actually there. Tinnitus is a phantom sound, a ring, a buzz, a hiss that exists only inside your head. There's no external noise causing it, nothing physically vibrating in your ear. And yet for some people, it never stops. The strange part is that tinnitus isn't actually happening in the ear at all. Most researchers now believe it originates in the brain, specifically in how the brain processes the absence of certain sound frequencies, often after some hearing damage. The brain essentially fills in a gap with static, like a radio tune between stations. But why the brain does this, why it picks a specific pitch, and why some people hear it constantly, while others with identical hearing loss hear nothing, is still unresolved. There is no cure, only management. And for around 10 to 25% of adults who experience it, that ringing is a permanent soundtrack medicine still can't fully explain, let alone silence. Sixth, and this one might take you back to childhood, growing pains. Nearly every kid gets them. Aching in the legs, usually at night, that seems to strike right when they're going through a growth spurt. Parents have repeated the same explanation for generations. Their bones are growing faster than their muscles can keep up. Here's the twist. That explanation has never been proven. In fact, several studies have found no direct link between the timing of growth spurts and the timing of these pains. Bones don't actually stretch muscles in a way that would cause pain like this. Some researchers now think growing pains might be related to lower pain thresholds in kids at certain ages, or even psychological factors tied to daily activity levels. Others still lean toward a musculoskeletal explanation we simply haven't identified yet. So that phrase your parents used, "it's just growing pains," was doctors quietly repeating a folk explanation that medical science still hasn't confirmed. Seventh, that chill that runs down your spine during a powerful moment in a song. It's called frisson, and if you've ever gotten goosebumps during a key change or a big emotional swell in music, you've experienced it. It's oddly specific. Not everyone gets it. Studies suggest only around 2/3 of people ever feel frisson at all. Brain scans show that frisson activates the same reward regions as areas flooded with dopamine. But why music, specifically unexpected shifts in music, would trigger the same chemical reward system as a life-sustaining need is still debated. One theory suggests it's tied to an ancient survival response to sudden environmental changes, like a temperature drop or a threat, that got rewired by our brains to respond to musical surprise instead. It's a compelling idea. It's also completely unproven. What we do know is that people who experience frisson tend to have a specific difference in brain wiring, more connections between the auditory processing region and the emotional centers of the brain. Why some people have this wiring and others don't remains a mystery. Eighth, and this one is genuinely unsettling, phantom limb sensation. The majority of people who lose a limb continue to feel it. Not just a phantom presence, but often specific, sharp pain in a limb that no longer physically exists. Some amputees report feeling their missing hand clenched into a painful fist for years after the amputation. For decades, the leading theory was that the brain simply hadn't updated its map of the body. Your brain has a detailed internal model of where every part of you is, and after amputation, that model doesn't automatically erase the missing limb. But that theory doesn't fully explain why the sensation is so often painful rather than just present. Newer research points to changes in the spinal cord and rewiring in the brain's sensory cortex, where the region that used to process signals from the missing limb gets invaded by neighboring regions, creating confused, often painful signals. No treatment reliably works for everyone. Mirror therapy, where patients watch a reflection of their intact limb to trick the brain, helps some people and does nothing for others. That inconsistency alone tells you how incomplete our understanding still is. Ninth, why watching someone yawn makes you yawn too. You've probably yawned at least once just reading this script. Contagious yawning is real, and it's not just in humans. Dogs yawn when their owners yawn. Chimps yawn when they watch videos of other chimps yawning. But nobody agrees on why. One theory says it's tied to empathy, since studies show people who score higher on empathy tests are more likely to catch a yawn from someone else. Another theory says it has nothing to do with emotion at all, and is instead a primitive way for groups of animals to synchronize alertness, a leftover survival tool from when staying alert together kept the group safe. A third theory suggests it's about brain temperature regulation, and seeing someone yawn simply triggers your own brain's built-in cooling reflex. Three completely different explanations, all with some supporting evidence and no consensus. Even something as universal as a yawn spreading across a room is still, technically, unexplained. The one that might be happening to you tonight. The hypnic jerk. That sudden, violent, full-body twitch right as you're falling asleep, sometimes paired with the sensation of falling or tripping over a step that isn't there. Nearly 70% of people experience this. The most common explanation is that as your body relaxes into sleep, your brain briefly misreads the muscle relaxation as an actual fall and fires off a panic signal to catch yourself. It's a good theory. It's also unconfirmed. There's no clear reason why this specific misfire happens to some people almost nightly and to others almost never, or why it seems to happen more often when you're sleep-deprived or stressed. So tonight, as you're drifting off and your whole body suddenly jolts awake for no reason, know that you're experiencing something science still hasn't fully cracked. Your brain, mid-transition between two completely different states of consciousness, briefly glitches, and nobody can tell you exactly why. 11th, why a heart attack can make your arm hurt. This one trips up even doctors in training. Referred pain is when something is wrong in one part of your body, but you feel the pain somewhere else entirely. A heart attack often shows up as pain in the left arm or jaw. A problem with your gallbladder can show up as pain in your right shoulder blade. None of that makes obvious sense since the arm and the heart aren't anywhere near each other. The going explanation is that pain signals from your organs and pain signals from your skin sometimes travel through the same nerve pathway into the spinal cord. Your brain, receiving a signal through that shared pathway, isn't always able to tell exactly where it started, so it guesses, and it often guesses the more familiar location, your skin, instead of the organ. That's a reasonable model, but it still doesn't explain why referral patterns are so specific and consistent from person to person, or why some organ problems refer pain and others don't. Doctors treat referred pain as a diagnostic clue every single day, while still not fully agreeing on the wiring behind it. And 12th, one of the strangest ones on this list, the placebo effect. Give someone a sugar pill and tell them it's real medication, and in a significant number of cases, they actually get better. Not just report feeling better, measurable changes happen. Pain drops, inflammation markers shift. In some studies, placebo treatments have triggered real, physical dopamine release in the brain, the same chemical involved in actual pain relief medication. Here's what makes this so strange to researchers. It works even when people are told it's a placebo. Studies on what's called open-label placebos found that patients who knowingly took a fake pill with full transparency still experienced real symptom improvement. That result breaks the simplest explanation, which was that placebos only work because people believe they're getting real medicine. If that were true, telling someone the truth should erase the effect. It doesn't. Something about the ritual of treatment itself, the act of taking a pill, seeing a doctor, being cared for, appears to trigger real biological changes that medicine still can't fully map out.